Good morning, everybody. Welcome back to using Python and GIS. This is a continuation of our massive process, our pre-processing of Landsat imagery. If you remember from last time, our script, when we got done running our script last time, it created this directory structure with the satellite name, the satellite date, the scene date that we're using, and created all these folders inside of that directory. Then it used the tar extract and extracted all of our satellite scenes into our root directory. Okay? It also wrote the results of our meta file to a database. And that database we called Insat Process, and it looked like this. Okay? I was happy at the results that it did exactly what I wanted it to do, but I was not happy as a GIS professional of working with a vertical database like this. And when I say a vertical database, I mean a database that has multiple rows that are of the same key item. All right? So I have band 1 here, band 1 here, band 1 here, and I have another fourth one further down. All right? This, in my opinion, is a horrible way of doing a database. It is so hard to work with. Okay? So what I wanted to do was make this database a lot more efficient. So I wanted this database actually to be like this. I wanted a separate line. I wanted a separate line for each band. And then in each band, I have the numbers that I want to work with. That way I can do a selection or use a for loop to loop through this file line by line and get the information that I want. Okay? So that was the ultimate goal of between the last video and this video. Plus I wanted to take us to the next step, and that is actually doing some raster calculations and create some new rasters based on that database input. Okay, so let's go back to our Python script and take a look what we did last time. Here we created our dbF file. Actually, we created our dbF file. The dbF file already was existent. All we're doing is writing the results to it. Okay, and this was the portion of the script where it did all that. You guys remember where I assigned all the values to each field, and that's what it did here. In terms of creating a horizontal file, I mean a vertical file, it was pretty darn short on how to do that. But since I wanted to search through and get all those lines that are the same band and put them in a certain order, things got a little crazy. So this is what that process looks like. I had to do a lot more file parsing in order to get it out into the format that I wanted. Okay? So I'm creating more variables for each band and writing those to a corresponding variable for the band and for the item that I'm interested in. These print statements were only for my testing, so I can have it report back what it's doing. Then it assigns them, it assigns all those values to a list for each band. So each band has a unique list of values. And then I write those lines to a new text file. I had to create a third text file in order for this process to work. All right? Then it goes into the new text file, that brand new text file, and uses it creates the new database in this format here with band and then all the different numbers that I needed to use in my raster calculations. And then write those to the database down here. The part of reading from the database and writing to the database exactly the same. It's just that I had to create a whole bunch of new types of variables in order to make that work. Okay, I will give you a link or the text to this code as well. All right. So this creates this process created our new database of values that we're going to work with. It creates this new satellite database. All right, and that's the format that we're writing it to. So each row is a band, and I have all the information for each band on a single row. All right. Any questions? Of course, you can't answer me right now, but if you have any questions, write it in the comments. And when you see that mess that I had to go through to create that database, if you have a way of looping through that to make this more efficient, I am open to see your solution. Okay? I am not a programmer, but we have to know Python in order to create some tools. All right? So I am open to comments for you guys to try to make this part, making that database a lot more efficient. Okay? But like I said, I'm not a programmer, and this worked for me. Just I had to write a lot more lines of code. So now we have a new database file in the format that we want. Now it's time to get to work on processing those raster images and put those in their corresponding folders for radiance and reflection. We're doing atmospheric, it's not really atmospheric correction, but they call it atmospheric correction. But we're creating these radiance and reflectance rasters. So we go back into Pi, and of course I always start with a test model first, and I added a couple new items for the output name. In this case is they're all going to be band rad or ref with a number behind them, and the input are always TIFF, so I put a band extension of TIFF. Then I hard-coded in my values instead of reading from a database. So I took band 1 and put its radiance numbers for multiplier and additive in there, and I assign them to variables. Then I go in and I create my new raster, and my new raster is the input raster is the TIFF that I download from USGS or unpacked the TIFF from the USGS file. And then I create a raster for that in the calculator. And that is just a simple record by saying my RAS, in this case, my raster, is the same as here. Okay? Now, I could have skipped a step and put the OS path join right in front of here and totally skip this line out. But anyway, I use the input raster in this RAS module, method, and do my calculations for creating the radiance image. And then the results get saved to a raster called test rad mult. Okay? Now, this raster method has to be called from arcpy spatial analyst. Okay? And that is, so I had to import the spatial analyst portion of arcpy and then check in the spatial analyst extension. If you don't have spatial analyst as an extension to your ArcGIS, this will not work. Okay, just so you know. There are there are open sources of ways of doing this using GDAL and GP module. Okay, you can do this with open source data, but the methods are different. Okay. So if you have ArcGIS and you have Spatial Analyst, this will work just like this. All right. So here we have our test script that we're only working with band 1 in this case. And we write this to test rad. And I right click and run in my script. And what I get is, here is our original TIFF image that we downloaded from the USGS. And it has values 0 through 20,000 something, okay? Most of your Landsat images will be in that range. This is the original digital number for each pixel, okay? After we ran our radiance correction, which is the TIFF image times the multiplier plus the additive. And that gives us new values ranging between -61 to 247 in this case. Okay, this is the reflectance, the radiance values for band 1, based on the map algebra. Okay. Now, how do I know that this worked correctly? Well, easy. I just went into Arc Toolbox and selected the raster calculator and inputted the same values into the raster calculator, named it a certain file, and wrote those results out. Okay? And I compared them with the output of my test run from my Python script. Okay, so I did the raster calculator. And I inputted the values. I hard-coded in the values. So that was the multiplier times the input TIFF plus the minus 61.99916. Then I saved it to a file and hit OK. All right. Then I looked at that image when it was done and I compared it to my test rad, and they were identical. Okay. So the next part of the script would be to put this into our main script, but make some variable changes because of the calls and assignments that I make, and put that all inside of a for loop, so it reads each line of my dbF and assigns those values to all the coefficients that I want to use. And then I just input my operating system paths and stuff, but everything's the same. I just had to change some of the variables because I'm not hard coding any of the values. And then I save it to my output, which is my radiance directory plus the name of the band, which is right up here, band_rad with a number behind it. Okay. When that gets done, so I run this file and it does it for every band, 1 through 11. And I get in our directory structure, if I go to the radiance directory, I get all of my new bands for radiance. Okay? Then I can bring those in Arc and do whatever I want. Okay? Now, the next step of this process was I not only want to create the radiance files, but I also want to create the reflectance files. But again, since I'm using that new Satellite.dbf, I can get everything that I need in one shot. So not only did I assign the radiance numbers to their corresponding fields, but I also got the reflectance values and assigned those to a variable. Then, right after I run the raster calculator for the rad and write the results to its radiance directory, I do the exact same thing. Now, I haven't commented it out because I didn't want to do them both during testing. I write the results for the same thing except for the reflectance. And so I just uncomment these out, run the program, and it will do both the radiance and the reflection, one right after the other. So when I get done, not only will I have all the bands for radiance, but I would also have them for reflectance as well. The next step that I'm going to be doing is I'm going to take this, put it in our massive script that we have, since it all works, and put that into the script that we're using inside of ArcGIS, and then run it. Then I don't have to type anything. Nothing's going to be hard-coded except for some path names. I can, I can just select the text file that I'm interested to process, do the unpacking of the image, and then create the radiance and reflectance and all that. Then after that, the next video is going to be creating some indices, such as your vegetation index, your burn index, and things like that. And that's going to be basically the same thing we did for radiance, except we're no longer using certain values. We are adding, subtracting radiances with radiances and reflectance with reflectance for different bands to create our normal difference, vegetation index, etc. Okay? So I hope you like this video. I'm sorry it's a long one again. I will try to put the code in the description of the video or give a link to the Python file so you can copy it down and do whatever you want with it to follow along. I appreciate all you subscribers. Thank you very much for subscribing to this channel, and please share these videos and help people see what I'm putting up here, and be sure to hit that bell for notifications for new uploads. You guys have a great day, and thanks for joining, and we will see you next time when we create some indices, whatever the correct word is. Have a great day. We'll see you later.